This conference will now be recorded.
Hi everyone, welcome to this next class of Introduction to Data Communications. So the topic which we would like to discuss today is the models used in data communications. The two popular models that we can use in data communications are Open System Interconnection model, which is developed by ISO organization. The second one, which is used part of ARPANET, called as TCP IP protocol suite. The first model basically focused more on different layers and their functionalities. And the second model is basically focusing on the different suite of protocols used in each of the layers. Fine. Let us go into detailed study of different layers and protocols used in different layers. So the topics which we would like to cover as a part of this class is the OSI model, what are the different layers of it, and what are the functions performed by the different layers. Then we'll try to understand the TCP IP model, the different protocols used in TCP IP model, and then we would like to have a comparison between the TCP IP model and OSI model. After understanding these two models and their differences, then we'll try to focus on the addressing concepts. Okay, right. The OSI model. So, as we said in the beginning class, OSI stands for Open System Interconnection, which actually means and it tries to connect the different systems irrespective of their models. Okay, so OSI model is a layered architecture model consisting of 7 layers with its topmost layer as application layer, followed by presentation, then session, then transport, then network, and next data link, and finally physical layers. If I am talking from 7 to 1, it is called top to bottom approach, and whereas if I am referring the layers from the first layer to the seventh layer, it is from physical to the application, it is called bottom to top approach. Okay, right. First, we have been introduced that open system interconnection model has been developed by an organization called International Standard Organization. And basically, open system interconnection is based on a concept called open system. But what do you mean by open system? An open system is a set of protocols that allow any different systems, any two different systems to communicate regardless of the architecture. One may be a window, one may be another format of operating system. Or you can find the one is an Apple and someone is a Dell, but still the devices need to be communicated. The architecture is different, but still the communication is happening. And how that happens? Then it only happens when the communication model is an open system. And your open system interconnection model is based on this concept of open system. It facilitates to communicate between different types of systems without requiring changing the underlying hardware. We talk about a person talking English and another person no Hindi. The communication to happen, there is a need that they need to have a common language. Either the English person need to know the Hindi or an Hindi person need to know the English. But when they have an open system, irrespective whether this person knows the other language or not, they're able to understand what the other person is communicating. This is the same thing happening. If your model is open system without need of any additional hardware or software, these two systems of different manufacturers are able to communicate with each other. An OSI is a layered framework consisting of 7 layers, defining the process of information across the network. The first thing that we would like to discuss in our OSI model is layering scenario. To implement and design a computer network which is general, cost effective and robust, there's a requirement of network architecture. The Okay, so layers provide various services, and whereas protocols govern the rules and procedures that govern the communication. Now look at this architecture. Here we are referring to protocols between the peer-to-peer layers, whereas the interface is talking about the bottom layer trying to provide a service to the hyper layer, right? Same layers are called peers, and between the two adjacent layers, we have the interface. An open system interconnection is one of the most flexible, comprehensive, and interoperable system. Let us try to understand this. Okay, and as we said, between the devices, we need certain intermediate nodes like routers or switches. If we talk about a router, which is only a network three-layer device. That is the reason why you could find only three layers present for this intermediate nodes. If it is again a device, they would have been seven layer, right? Clear. So network layered architecture refers means we are trying to design a network which is being robust, general, and cost effective. And here we are trying to understand the functions of various layers and the interfaces used between different layers. At the same time, how the peer-to-peer would like to communicate with each other. As per the bottom to top approach, the first layer of OSI model is called physical layer. Now the physical layer generally tends to receive the data from the data link layer. The data link layer transmits the data in form of the frames and which are received by the physical layer, and then these bits are converted into zeros and ones. It is trying to move data in form of electromagnetic waves across the transmission. For instance, if the data transmission medium has to be used as an optical fiber cable, the physical layer converts these bits into in form of light. If it is a copper cable or a coaxial cable or twisted pairs, it would be sent as an electric signal, right? The signals which we can transmit from the physical layer can be an analog or digital signal. Next important function basically the work performed by the physical layer is the type of topology to be used in the network will be decided by the physical layer. And it also tries to understand whether the transmission mode to be opted is a simplex, optoplex, or full duplex. And the type of connections we are using to connect to other devices, whether we have to go use for point to point or we have to go for the multi-point, will be decided by the physical layer. At the same time, the data rate will also be identified by the physical layers. So, in short, or in summary, what are the functions performed by physical layer? The first and most important is the physical layer receives the data from data link layer, converts into zeros and ones, and depending on the transmission medium, because the selection of transmission medium is taken by physical layer, it converts into either an optical signal or an electromechanical signal. Then it is on which actually selects the transmission medium, then decides the topology to be opted. It decides whether we have to go for point to point or multi point, and it decides what is the data rate to which transmitted. And then it also be trying to move the individual bits from one hop to the next hop. These are the basic functions performed by the physical layer. The layer above the physical layer is called data link layer. Now, we could find from the previous slide that data link layer receives and forwards the data to the physical layer. But data link layer receives the data from its next higher layer called network layer. Now, one of the major functions performed by data link layer is it implements node-to-node delivery. Now, let me try to understand you what do we mean by node-to-node delivery. Now, I'm the source called end system A and would like to communicate to the end system F. Source is A and destination is F, but A is not directly connected to F. So what in that diagram you can observe that the data is first transmitted from A to B through this link, then it tries to find it has to reach to BF. So it transmits from B to E and then finally from E to F. right? So node to node delivery means A to F is not directly connected. The first data moves from A to B, then B, it is not directly connected to F, so it moves to B to E, which is in the path from A to F, and after E, it will be identifying and trying to send the data to F. So this transmission into B, B to E, and E to F is referred as node-to-node delivery. Clear? This is one of the major functions performed by the data link layer. The next function which a data link layer performs is it receives the data from network layer, and to that data it will be adding the two inputs called header input and trailer input. The trailer will be used for error detection and correction purpose, and the form of data plus the header and trailer together is called as frames. So one of the more function performed by data link layer is framing. Along with this, we have learned in our introduction that data link layer ensures whether the data received is error free or any error is detected. If error is detected, how the error is going to be corrected. So error detection and correction, together called error control, is one more function performed by the data link layer, right? There is one more scenario which we discussed previously is if sender is continuously transmitting, but receiver does not have that capability to receive, there is an overflow and loss of data. To overcome this particular problem, we have to ensure the rate of data transmission is in the limits of receiver. And this particular function is implemented by data link layer, and this function is referred as flow control, right? So we have error control, flow control, framing, node to node delivery, and one more important function delivered by data link layer is it generates an address which will be helping for implementing of node to node delivery. And that particular address is called the MAC address or physical address. And next important function performed by data link layer is when we have multiple devices trying to use a common resource, in which turn which particular device have to use it will be decided by the data link layer, and that is called as access control. We are going to understand in detail access control function performed by data link layer in terms of random access, control access, channelizations. So let's wait for some more time, and we are going to discuss all these topics in our unit number 2. Okay, so these are the functions of data link layer, right? So first we talked about physical, then we now talked about data link layer. The layer which is above the data link layer is called as network layer. The major function associated for network layer is routing of data from source to destination. So major role performed by the network layer is routing of packets from source to destination. And how this particular routing of packet from source to destination happen is it uses one more address called Internet Protocol address or logical address, which is also called as universal address. We'll talk about it in the coming slides. Next important thing that network layer tries to perform is it tries to receive the data from the transport layer, which is above it, and adds it header. Okay, so this is called the function of network layer, converting the data received from transport layer into units of data called packets, which is also referred as datagrams. So your data link layer is responsible for node to node delivery, but whereas your network layer ensures it is going to implement from the source to the destination. So this is the reason why network layer is said to be executing a type of delivery called end-to-end delivery. Okay, so hop-to-hop delivery between two adjacent nodes will be carried out by data link layer, and the end-to-end delivery performed will be taken care by network layer. DLL will be taking care of hop-to-hop, and network layer ensures it will be taking a function called end-to-end delivery. I hope I'm clear with this. Next, the other functions which are performed by network layer is logical address, which is ensuring the end-to-end delivery. What is the basic thing happens is, suppose A source and F is the destination, but in the node-to-node delivery, A cannot directly reach to F. So initially, A will be the source and B is the destination. Next, B becomes source and E becomes destination. Finally, E becomes source and F becomes the destination. So the MAC address changes from node to node delivery, but we find the IP address, which is called logical address, remains same. And that is the reason why your IP address will be referred as universal address. Okay, so the IP addressing and routing of packets is one of the major functions performed by your network layer. And third important is it ensures end-to-end delivery. Now, in the beginning of the introduction of the subject, we said the communication not only has to reach from source device to the destination device, but it actually needs to reach the application of the source device to the application of the receiver device. So that particular mode of delivery is referred as process to process delivery. And the layer which is responsible for the implementation of trans, uh, process to process delivery is called as transport layer. And here what happens is the transport layer receives the data from its upper layer called session layer and tries to divide the data into smaller units called segments. So in the data link layer, data is in form of frames. Network layer, data is in form of packets, and in here transport layer, the data is in form of segments. And to identify different processes running on a device, each process is provided with a specific number or address called as port address. And the port address is the one which actually helps in implementing of process to process delivery, right? And what is segment and why do we need and how it particularly implemented in transport layer is sometimes what happens is the total amount of data to be transmitted might be much greater than the capacity of the network. For instance, the maximum capacity is 1000 KB and total data is 1500. So can't we say, can we send that totally at a time? No. So what does the transport layer do? It is going to divide the total data into two segments. The first segment of size 1000 KB and then the next segment will be of 500 KB. And those two individual will be referred as segment 1 and segment 2, given with an identification numbers called sequence number, and we are given a number 1 and 2, right? These two segments will be transmitted to the receiver, and after receiving the two segments, and they belong to the same set of data, and again they are combined into a 1500 KB data. That is what we are referring as a function called segmentation and reassembly. The transport layer and the source will be implementing segmentation process, whereas the transport layer of the receiver is going to implement the reassembly process. Next important thing is based on the type of connection, whether you are trying to go for connection oriented or connectionless, the transport layer is going to select you the particular protocol. If it is connectionless, we use UDP, and if it is connection oriented, we are going to prefer transmission control protocol. And along with data link layer, even the transport layer ensures the flow control and error control process has been happening. Something like if data link layer has missed something in the error identification, that will be taken care by the transport layer. Okay. And as we said, this host to host or node to node, end to end transport layer is process to process delivery. Right. So the next layer above the transportation layer is called the session layer. And basically, the session layer is responsible for implementing of sessions, and that is dialogue initiation and also for synchronization of the data. Dialogue control. What do you mean by dialogue control is whether the communication which we have been trying to implement is an half duplex or a full duplex. At the same time, trying to create a synchronization between the sender and receiver will be performed by the session layer. When to be sent? We have heard in the protocol that we have three functions called syntax, semantics, and timing. And so session layer is concerned with the timing function. Whereas the presentation layer, which is above the session layer, is trying to understand what is the data to be transmitted. It will be taking care of three important functions called translation, compression, and encryption. So we know translation function, which makes sure the data is translated to a version which is understandable to the different devices. And compression, when you have a large bulk size and you want to reduce it, that is what you call as compression. And for security purposes, we use a function called encryption. So presentation layer is concerned with these three important functions called compression, encryption, and translation. Session is used for dialogue control and synchronization. Presentation is used for encryption, compression, and translation. So we are receiving the data from the seventh layer called application layer and implementing these three important functions called encoding, encrypting, and compressing, and forwarding to the next layer called session layer. Now at the receiver end, we have the reverse process. Like at sender, we have encoding, encrypting, and compressing. Here we are going to have the reverse functions called decoding, decryption, and decompression. Then trying to forward the something like we zip the file to reduce the size of the file. And again at the receiver, we'll unzip or extract the file to get the original content. This is similar. And finally, the most important layer, which is responsible for the implementation of this data communication, is called an application layer. It is responsible for providing services to the user and various types of services depending on the protocols it uses, like file transfers, access and management, directory services, and all. You can find just a second. Dialog and network virtual terminal, file transfer, access and management, mail services, and directory services will be taken care by the application layer. Okay. Now these are the different layers and their functionalities. Now everyone are a bit confused, so I try to be rush. So let me simplify with a simple diagram to understand exactly what are the different layers involved in OSI model and what are the functions performed by each of them in one simple tag. And here it is. So let me start. Someone on highlighter. We start with physical layer. And what are the functions performed by the physical layer? To transmit bits over a medium, then it tries to select the topology. There is a transmission medium, and depending on transmission medium, it provides electromechanical specification or optical specifications. And beyond that, it also tries to help you in making a selection of what type of connections, whether it is a point-to-point or multi-point, will be identified by the physical layer. The type of topology to be used is also decided by the physical layer. And coming to the data link layer, it performs functions like framing, where it's converting the data into form of frames. It provides node-to-node delivery. Then it is also responsible for flow control, error control, and it generates a MAC address which is responsible for the node-to-node delivery. Next layer which we discussed is network layer, which is above the data link. And the first function it performs is converting the data from transport layer into packets. It is responsible for the routing of the packets, and it is important for the end-to-end delivery. And to implement the end-to-end delivery, the network layer uses an address called IP address, which is also referred as universal address, right? The next layer is transport layer, which is responsible for process to process delivery. And to implement that process to process delivery, it is going to use an address called port address. Beside this, the limit of the capacity of the network is less than the total data transmitted. It is going to divide the data into segments, and later it is going to reassemble the segments into a unit data. At the same time, if some of the functions of data flow control and error control are missed in data line, we'll again taking care of transport layer. Right. The session layer is actually used to establish, manage, and terminate the sessions, and it is responsible for the dial-up control and synchronizations. The presentation layer is concerned with encryption, encoding, and compression of data. The receiver end it is going to perform decoding, decrypting, and decompression of data. And finally, the application layer to allow the access the network resources. Okay, so I hope this slide gives you a summary of what all we discussed for the last 20 minutes, and I believe you people can also make a quick more remembrance of this, and believe maximum of the question papers definitely you could find this particular question called explain OSI model and the functions, or explain in detail about OSI model. Believing that you people got some inputs for now and revise it twice or thrice, and definitely you will be able to attempt this question without much trouble. Right, this is our first model. Coming to the next model, which is called TCP IP model. Now, if you can observe in the previous scenario, you have been talking about different layers and the functionalities which are performed by the different layers of OSI model. In this particular TCP/IP protocol suite, we are going to focus on a terminology called protocol, and that protocol which refers to the set of rules and procedures that govern the communication between the source and the destination. In each here, we are instead of having a 7 layered model like in OSI, we can either refer it as a 5 model or 4 layer model. When you are combining data and physical layer, it can be referred as a 4 layer model. If you're treating both them separate entities, then you can refer it as 5 layer model. In case of TCP IP, we are going to combine the presentation layer and session layer as a part of application layer. So totally you can refer it as a 4 layer when it is combining data and physical, or if you're separating them, it's in 5 layer model. And as I said to you, here the focus will be more on the different set of protocols used in the layers of TCP IP. Now just look at the figure. Here you can find the letters in the red color indicating the different set of protocols used in the TCP IP. Starting with host to network, which is a combination of physical and data link, we have protocols like X.25 and LAN protocols. When you talk about second layer called network layer, we talk about protocols called Internet Protocol, IP, ARP, RARP, and ICMP. So in brief, ARP and RARP basically are trying to use. Now, one of the important functions which we discussed in the recent time was Internet layer is concerned with IP address or logical address, and data link layer is concerned with MAC address. Now, instead, if you know the IP address but you don't know the MAC address for a device, the type of protocol we are going to use is called address resolution protocol. But there is a different scenario where you know the MAC address but you don't know your IP address. Then the type of protocol we are going to use is called as reverse address resolution protocol. The third, internet protocol, which is IP, which is responsible for the end-to-end delivery. And the address associated with it is called IP address. And the current version which we are using is IPv4, and very soon we are moving from IPv4 to V6, and IPv4 is a 32-bit data and IPv6 is a 128-bit data. Okay, I'm sounding good, right? So along with these three protocols, we have two more protocols in our network layer called ICMP and IGMP, which is called Internet Control Message Protocol and Internet Group Message Protocol. Right? TCP IP, which stands for Transmission Control Protocol Internet Protocol. It's a set of protocols that allow communication between multiple diverse networks. So TCP IP, here we are trying to combine physical and data link as host to network layer. We have internet layer, transport layer, and application, which is a combination of session, presentation, and application. So host to network layer, which is the first layer, is actually responsible for accepting and transmitting the IP datagrams. The internet layer is a similar functionality as a network layer, and it's the communication from end to end. Transport layer, which provides peer entities or provides process to process, right? So here is a quick look about what are the different protocols which are being used in our layers of TCP/IP. In application layer, you could refer protocols like Telnet, FTP, Simple Mail Transfer Protocol, and DNS. What do you mean by this, and what are the functions? For instance, you want to connect yourself to a server of your office. So you are in a remote location and you are trying to connect to your office in your work from home scenario. Then the type of protocol which is involved is called as Telnet, which is called Remote Login Terminal Network. Right? You are sitting at home, but you are working as if you have been sitting in your office. That is what how happened. That is because of Telnet protocol. Or similarly, I want to attach a file to a mail. The type of protocol I have to use is called file transfer protocol. After attaching it, I need to send a mail. The protocol I have to use is called Simple Mail Transfer Protocol. And transport layer we have, which is offering two different types of services. One is connection oriented, which is called TCP, where you get reliable and connection oriented transmission. And when you are not looking for a connection and you don't want reliability or unreliable is okay for you, you go for the other set of protocol called user datagram protocol. Basically, the purpose of the transport layer here is to provide the byte streaming of data, and it also tries to divide the message into segments and reassemble at the destination. An internet protocol or internet layer, which we have talked about, consists of five different set of protocols, namely internet protocol, which is the main protocol and which is supported by ARP, RARP, ICMP, and IGMP. So IP is the main protocol to mine the data. It is responsible for the routing of the data. It provides services such as fragmentation and addressing. So any kind of error in the transmission, something like if I put a wrong mail, I miss one letter in the alphabet in the mail, I get an error message could not transfer. So that is called the control internet control message protocol. And we said when you want to send a single message to multiple receivers or destinations, the type of protocol involved is called internet group message protocol. And you know your IP address, you don't know MAC, you use ARP. And you know the MAC and you don't know the IP address, we are going to use the reverse address. And in your host to network layer, we have been using protocols like X.25 and different LANs. And we'll have more understanding of it in the coming topics. So this is a simple comparison of TCP and OSI models. So TCP is basically talking about four layers with different protocols, and your OSI is more focused on different layers, the seven layers and their functionalities. I hope people will be able to understand this. Here is a quick glimpse of what is the differences between OSI and TCP model. So before this, let me just put a small video related with our discussion. Okay. So they have been trying to explain the different differences between the TCP and IP model, which we would like to discuss in form of a table. Let me just put it on the screen. Right. So first and major difference identified by us is that TCP/IP is a 4-layer and OSI is a 7-layer model. Model was designed before implementation of protocols. It's OSI, but it is designed after the protocols, which is called TCP/IP. Basically, your OSI is focused on three concepts that is called service, the interface between two adjacent layers, and peer-to-peer protocols. OSI does not guarantee the reliable delivery of packets, whereas TCP gives it. It's strictly layer and other is loosely layer. It supports both connectionless and connection oriented, whereas TCP only connection oriented communication will be supported. Okay, these are some of the major differences between the OSI and the TCP model. The last topic which we are going to discuss before we end up is different types of addresses which are used in TCP IP. So based on the layer and the functionality, totally we have four different types of addresses. First one is physical address, the next one is IP address, third one is port address, and fourth one is specific address. Now coming to the first, which is called physical address, it is associated with a layer called the physical address is concerned with a data link layer, and then logical address or IP address is concerned with the internet layer. Then the port address is concerned with the transport layer, and specific address is associated with the application layer. Right? So what are the functions of each of this? Right. The physical layer, which is also called link layer address or MAC address, is responsible for node-to-node delivery. The data link layer frame contains physical address in the header. It changes from node to node, right? It receives data from the network layer, encapsulates into the frames, adds the header, and then separates forms to upper layers. The length of this physical address is 6 bytes. Now remember, the major function delivered by the physical address is the node-to-node delivery. But exactly what is required is not just node to node, but we want end-to-end delivery. And that is only possible with the help of second set of address called logical address, which is also called as IP address. And node to node, we may have a change of source and destination address, but in end-to-end delivery, we need to have the IP address remain unchanged. That is the reason why the IP address is called universal address. But in the destination of the host, we want to ensure the concerned application is exactly receiving the data which has been transmitted by the other end. And that can be happen only because of transport layers process to process delivery. And to implement the process to process delivery, we need a port address. And last but not the least is the specific address which is related with the application layers, like a simple mail address which you could find. So that is an example for your specific address. And a simple slide is actually trying to show you what an IP address is, and then you can find out the MAC address, the physical address, and then you could find here you can find the physical address, and then we're also going to talk about IP address. In every system, just try to look at the internet connection, and then you are able to identify that. Okay, I hope with this, you people are able to understand what are the different models we have to understand the data communications, what are the layers, and what are the different protocol suites, the comparison between the two models, and last but not the least, what are the different addresses used by different layers. I hope this understanding is very important because their entire remaining syllabus will be dependent on this particular class, right? So just try to understand what are the layers, what are the functions performed, and then what are the protocols used in different layers, and what are their functionalities, and what is the comparison between the two models, and last but not the least, what are the different set of addresses associated with each layer. With this, we would like to hold our discussion for now. We'll try to discuss one last topic called wireless LANs in our next class, and I hope we people got a clarity on what exactly the models, what are the layers, and the functionalities of the layers. Meet you in the next class. I hope things are clear. Thank you.